Hello, my name is Jake. I'm just going to do a quick little tutorial of using PyMOL to visualize trajectories, specifically trajectories where you are also trying to change the camera view. I had a lot of issues trying to figure this out myself. There was a good tutorial from pymol.org, but it was a little bit complicated. I think it could be made clearer. So what I did, this is from an attach pull release simulation using the Paprika framework. The trajectories produced are as follows. We see a ton of folders starting with the job ID, and then our attach, apply restraints, attach energy minimization, etc., etc. And within any of these given folders, we should see an input PDB, so the structure that it started the trajectory with, as well as our trajectory that it followed to reach the output PDB here. What we're really interested in is the trajectories. We don't really care what each individual input is, as long as we start with the first input. So what I went ahead and did was just I extracted the very first input into a folder, and then inside of that folder I also extracted all the trajectories. So I have a folder of just pure input and trajectory, and so you see here low users input.pdb, that's just my starting structure. And the reason I'm using code for this is to just make it a little bit easier to interface with PyMOL. I'm just using this command window here, and since it's very, very, very repetitive, I don't want to be typing in the same command 400 times, so I just decided to generate a list of commands that I can copy paste to load everything in. So this is for I in range 0 to 46, just because I have 46 of these. If we go to, let's see, pull production here, or this will be good enough. So pull align coordinates, we see it goes all the way from 0 up here to 45.1 down here. And each of these numbers has a 0 and a 1. So I am adding the 0 and then the 1 trajectories together. And then their state that I'm adding is going to be equivalent to the number of states I have total. So I found just through experimenting with my particular trajectories that when I loaded in a single trajectory into PyMOL, it was divided up into about 800 states. This might differ, and you might just need to take a look at what yours is. And so this state is essentially saying that starting with the first trajectory, I'm going to start at state 1, so I is going to be 0, and this is just going to be 1. And then with the same I value of 0, the second trajectory, which is going to be this 1 version, is going to have state 401, it looks like. Yeah, 401. And then when we have I is equal to 1 up here, we will have 801, so on and so forth. So there should be a 400 state difference. And like I said, that's just particular to my trajectories. It might be different for yours. So this code here is just ranging through, and it is going to type out this command, which is load trajectory, and then the path to load it from, which it's just in a folder on my desktop right now. And then I've got the iteration, and then the 0, the 1, and the trajectory. And I'm loading the input as this state, okay? So when I go ahead and I actually run this, it will generate a whole messy output for me, starting with load the trajectory, or excuse me, load the input PDB. So this is the beginning structure. And what I can go ahead and do is just copy this. So if I've done everything right, it should all be in order, and we should see, okay, it looks like I have 36,000 states. You could do a little bit of quick math to just check out and make sure that that makes sense to you for your trajectory. So I have, let's see, what is it, 46 of these, and each of them is taking up 400 states. That sounds about right to me. I'll go with that. So what I'm going to do is, now that I have that copied, I'm going to head into PyMOL, and I'm just going to paste it all in one giant command. It might take a moment. Let's see. All right, so everything is loaded, and we should see in the output read set blah, blah, blah into state blah, 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 and this is good. This is a good sign. So we have 36,800 of these states, which is, fine. It's plenty for us to work with. So what we can do now is start making a movie. So if we just scroll through really quickly, we can scroll through these states and just make sure it's different. And so, like I said, this is an attached pull release simulation. So we've got our guest molecule pulling out of the host molecule. I might back up a little bit so you can see it. Should be pulling all the way out, and that's where our simulation ends when it's this far out, or I guess a little bit more there. Those 3 atoms in the back are just dummy atoms to help with restraints. And yeah, so this is the entire simulation. Now what I want to do, what I have in my head as a goal, is I want to be able to watch this guest coming out of this host molecule while simultaneously having the camera move around, because it's a little bit boring to just watch it from this angle back and forth. So what I'm going to do is I'm going to start a movie. I'm going to say mset 1, 2. So this is starting with frame 1, and then whatever frame I want it to end on. So I'm going to do it such that it's 1 frame per state. This might not be the best idea, and this is going to give it a lot of noise, but it's just what I'm doing for example purposes. You could make it so that you're skipping, you're only including 1 of every 3 states as a frame, and that might be a little bit better because these states are going to be a little bit random. We're doing it on too big of a time scale to see smooth motion from state to state, so it's going to look random regardless. Either way, so mset 1 through 36,800, that should create our movie with a 1-to-1 frame to state ratio. And if we move through, we should see, let's move this a little bit. So we should see that as the frame here changes from 1 to 36,800, we should see the state changing exactly proportional to the frame. If you don't see that, there was a bit of a mistake setting up the movie, because you really want to make sure that as you drag this along, you're getting the same frame and the same state if you're doing a 1-to-1. Regardless of whether or not you're doing a 1-to-1, they both need to be changing. That's the whole idea. You don't want to just have 1 or 2 states. That's not going to work out to actually show the trajectories. So now that I have the movie created and outlined, I want to select some key frames. So let's say I want to begin the video with a very nice close-up view. So I'll go all the way back to frame 1, which is where I'm at right now. And then what I can do just graphically, you can also do this with commands, but I will just click store by right-clicking on this bottom bar here. Now that I've stored it, I can go to another frame. Let's say, I'll just do one in the middle, and then I'll say, okay, now I want my camera to be way far back over here. Now I'm going to do this again, and I'm just going to click store. That'll store it as this state, this frame. Then let's say lastly, the very end, I want it to be off to the side like this. And I want to get a nice big view of this, and I will click store. So hopefully we should see a bit of a movement going on here. So we start with this. Oh, and what I didn't realize actually until just now is when you right click on this bar here, you're actually storing it at the frame that you click on, not the frame you're currently on. So this might need to get moved in the future. What I might do is I might actually just purge this entire movie and just really quickly redo it. I'll say mset, and then I'll start at the very beginning frame, zoom in here, and I will go to the first frame and I'll say store, and then I will go to, let's say perhaps the last frame over here, and I will go to the last frame, and I will click store, and hopefully then we will see a nice smooth transition with the camera work, as well as seeing our trajectory in full. So we start out there, we zoom in just a little bit, and then slowly it will zoom out as we pull out our guest from the host. So as you can see, I had a little bit of trouble with trying to define where I'm storing these here. If you don't want to run the risk of storing it in a location you don't want, like for example, I didn't actually store the beginning at frame 1 because I'm at frame 1 and it's not quite where I stored it. It's going to take a little bit to get to where I stored it. It looks like I technically stored it at about frame 116. So if you want to get it really, really on the nose, you can use commands, just store it as that frame of the movie. Otherwise, this is good enough for my purposes. I can just see it coming out. And then you can do whatever you need to with PyMOL to just create your movie. now we have everything all set up and you should be good to go. Okay, thank you.